Hello and welcome. This is going to be our homework help video for the review for the Trig mini quiz. Start with converting some measurements of angle. Convert each degree measure into radians and each radian measure into degrees. Starting with number 1, we've got a degree measure. To get degrees into radians, you need to multiply by pi over 180 degrees. And when we do this, what I do is I ignore the pi at the beginning. I just do the division with just the numbers, and then I add the pi back in on top. So, well, what this becomes, let me write it, it becomes 135 pi over 180. The degree symbols cancel out. So I can just plug that into my calculator, 135 over 180. And then turn that back into a fraction, doing math, enter, enter, and then put the pi back on top. So 3 pi over 4. It's up to you if you want to write rad at the end of that. You don't need to write any unit with radians. For this next one, to convert radians back to degrees, I multiply it by 180 degrees over pi. Notice how that's slightly different from what we did in number 1, where I multiply by pi over 180. Now I'm multiplying by 180 over pi. This way, I will pick up the unit of degrees, and as an added bonus, my pi's cancel out. This here becomes negative 360 degrees over 3, which becomes negative 120 degrees. All right, find the measure of each angle. Let's do number 3 here. What I want to do when I find this measure is I want to follow the spiral, counting by either half revolutions or full revolutions. But just remember, if my reference angle is given in radians here, which I can tell it is because it doesn't have the little degree symbol and it has a pi, then I want to count in radians as I count my spiral. So here I put my pencil at the start. As I start to trace it, I go pi, 2 pi, 3 pi, 4 pi. So 4 pi to get to this unit right here. And now I can either undershoot and add or overshoot and subtract. For this one, it'd be easier to overshoot and subtract. So if I kept going around to here, that would be 5 pi. But I have to take away this little bit because I didn't go all the way to that point. So I'm going to do the operation 5 pi minus pi over 6. Let me turn that into 30 pi over 6 minus pi over 6, which equals 29 pi over 6. But then I check to see which direction was my rotation. You can have positive and negative rotation. Notice the first move I did right here was I went down from my x-axis, so that makes this negative rotation. You could also say clockwise is negative, which means that the true measure of this is negative 29 pi over 6 radians, or just leave it like that. State if the angles are coterminal. So here's one way we can do this. Let's practice it with the degree measures here. Is I need to take the difference between them. So I need to subtract, take whatever that is, and divide it by 360 degrees. So subtract, I'm going to get a number here. I'm going to divide it by 360. Then whatever I get, if it's an integer, they are coterminal. That means they are separated by a full revolution or a multiple of a full revolution. If I get a decimal, then they're not coterminal. So what I'm looking for is an integer. Let's get the calculator back out. 265 minus 625. 265 minus 625 equals negative 360. Divide by 360, I get a negative 1. Negative 1 is an integer, meaning that there's one full revolution between these two angles. So we're going to say yes, coterminal to number 5. All right, length of an arc. And we can leave pi in our answer if we do get pi. So looking at problem number 7. The formula for arc length is S equals R theta. Arc length S equals the radius times the internal angle there, theta. trying to get this bold section out here, figuring out how long this arc is from there to there. So what I need is the angle on the inside that makes that arc. So this is already in radians. If it was in degrees, we'd have to convert it, but I can just plug that in right there, plug the 15 in right there, get that S equals 15 times 5 pi over 4. S equals 75 pi over 4. And I think we'll just leave it like that. It says leave pi in your answer. And I don't think I can simplify that down anymore. But let's give it the unit of centimeters because it is a length after all. All right, find the value of the trig function indicated. Leave as a fraction. Let's do number 9 here. So if I'm trying to find tangent of theta, and I know that this is my angle theta, then I have to label my side lengths from this perspective up here. So standing right here, if I look out, this side over here is my opposite. Now my two adjacent sides, the longer one gets named hypotenuse and the shorter one gets named adjacent. According to SOHCAHTOA, tangent is equal to opposite over adjacent. So I need to do this opposite length here divided by this adjacent. But I don't know this opposite length. So to find this opposite length, I'll label it x and then use the Pythagorean theorem. I'll do that over here. 5 squared plus x squared equals 13 squared. 25 plus x squared equals 169. Take the 25 away from both sides. X squared equals 144. Square root, x equals 12. All right, so my opposite is 12. My adjacent is 5. So according to this, tangent of that angle theta should be equal to opposite over adjacent, so it should be equal to 12 over 5. And I'm just going to leave my answer like that. It says leave as a fraction, so that's good. All right, let's look at 11 and 12. Which one do I want to do? I'll do number 11. So from angle theta, I got to label my side lengths. Let's just label the two that we can see. I can see that I've got my opposite and my hypotenuse. Then according to SOHCAHTOA, it is sine that links opposite and hypotenuse. So I know that sine of this unknown angle theta is equal to opposite, 4.2, divided by hypotenuse, 10. To get theta by itself, I do the inverse sine to both sides. All right, so 4.2 divided by 10. Take the inverse sine, so second sine of that number, and I get 0.43. My guess is that's in radians. What did it want? It wanted degrees. So let me run that calculation again, but this time be in degree mode. If I run it again, I get 25.7 degrees, which looks about right. It looks like about a 25.7 degree angle. All right. These ones work slightly differently. We'll do number 13. I've got an angle and a side length. I need to find another angle. From the angle that's given, I label everything. Opposite, adjacent, and hypotenuse. And I look at what I have and what I'm missing, or like what I'm missing that I want to have. Adjacent and hypotenuse. Well, I know that cosine connects those. So the cosine of 35.2 degrees must equal adjacent 12 divided by hypotenuse of x. All right, cosine of 35.2. Let's get a number for that. 35.2, so cosine of 35.2. Make sure you're in degree mode because you're plugging in a degree measure into cosine. Get 0.817. 0.817 equals 12 over x. Swap these two numbers, get that x equals 12 over 0.817. I've got that number still in my calculator, so I'll just do 12 divided by second answer. Preserve the precision there. I have 14.7 units. Let's see, there's no unit given, so we'll just say units. 14.7 units of length. All right, find the exact value of each trigonometric function. Let's do number 17. All right, so I pick a point on my terminal side and drop a line down. With these ones that are already diagrammed, it's pretty easy to just take a guess and guess correctly what type of triangle we have. This really looks like this is the 60, making this a 30. We could double check that. Let's see. It's negative 11 pi over 3 to here, so that's negative, how should I count this? Now negative pi, negative 2 pi, negative 3 pi, negative 3.5 pi, which would be then negative 7 pi over 2. Oh, I'd have to convert these both to base 6. Maybe faster to convert that to degrees. But I'm telling you now, if it looks like a 60-degree angle, just go with it 60. With these ones down here, we'll have to actually do the math. We'll do number 20, where we have to do the math to figure out what the interior angle is. If it's given, just go with what it looks like. If this is a 30, 60, 90, then the side lengths must be 1, 2, and the square root of 3. I check to see if any of them are negative. None of them are, because we're coming over to the right and going up. All right, then I also label them opposite, adjacent, and hypotenuse. Then I look at cosecant, and I know cosecant is the reciprocal of sine. So it must be a hypotenuse over opposite for cosecant, which would be 2 over 1, which just equals 2. Number 17, I got 2. 2 root 3 over 3. Cosecant. Opposite of sine. Hypotenuse over opposite. Oh, I picked the adjacent. So hypotenuse over opposite. Thought that one sounded a little fishy. All right. Opposite is root 3. Can't have a radical in the denominator, so I multiply the top and the bottom by root 3. And I get 2 root 3 over 3 as my ratio. All right, that looks a little bit better. Let's do number 20. So number 20, I need to sketch a 5 pi over 3 angle. That's kind of the hardest part of this whole thing. Is what does a 5 pi over 3 angle look like? Straighter. Well, how can we do this? We can think of 5 pi over 3 is, well, let's just, if this is pi units, and I divide it into thirds, and divide it into thirds in the bottom, then I'd have 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3 would be to right here. So that's 5 pi over 3. So it's definitely coming down into this quadrant. Let me convert that into degrees real quick. Might help us out. 5 pi over 3 times 180 over pi. So the pi's cancel out, and I just get 5 times 180 divided by 3. So this is a 300-degree angle, so it's stopping 60 short of a full rotation. So this angle in here has to be 60, making this a 30, 60, 90. Let me draw that a little bit better. 30, 60, 90. The side lengths 1, 2, in the square root of 3, but this one now is coming down from the x-axis, so that makes that a negative side length there. All right, and we want cosine, so we want the adjacent over the hypotenuse, which is going to be 1 over 2, which equals 1/2. Number 20, I got 1/2. Yep. All right. Using radians, find the amplitude, period, and phase shift for each of the following. Let's look at 23. Amplitude is any coefficient here. Coefficient is just 1, so that's our amplitude. Period. Well, period is 2 pi over b. Our b value is 7. So it's just 2 pi over 7. That can't be simplified. Phase shift. So phase shift is equal to h over b. So my h value is negative pi over 3. We always flip the sign on that. Divided by 7, copy dot flop that, and we would get, and I like to just write left or right. It's going to be going left pi over 21. So the negative tells me it's going to the left, pi over 21. And then that 5 at the end gives us the vertical shift. Vertical shift up 5. All right, let's put this all to work as we attempt to graph one of these. I'll graph number 26 here. All right, so it's a cosine wave, so it should normally start at a maximum. All right, and then cycle back to that maximum every 2 pi. So here's sort of our cosine wave, just kind of dotted in. Not going to do too much with that because it's going to get moved around. One thing that's going to happen is that it's going to get vertically stretched by a factor of 4 because the amplitude has been shifted to 4. So let me change these dots to be 4 times as high off of the x-axis. Next thing is everything's going to go down 2. So I'm going to take all of these points and move them down 2 units. Down 2, down 2. I'm going from the purple now. Down 2, down 2, down 2, down 2, down 2, down 2. So let me get rid of the purple and the red. Blue is where we're at now. If I was to just graph it right now, I would just connect these up into a wave. All right, but we got a period shift and a phase shift, so we got to apply those next. The period is 2 pi over b. B right now is 1/3, so that equals 6 pi. So instead of doing a cycle every 2 pi, it's going to cycle every 6 pi. So it's going to still start right there, but it's not going to come back up to be right there until 6 pi later, meaning that at 3 pi it's at a minimum, and that at 1.5 it's halfway in between, which is 1, 2, 3, 4, 5, 6, 7, 8. So it's $4. It's down 1.5 over. So 1, 2, 3, 4. They're 1.5 over. 1.5 over. 1.5 over. All right. So now we're at the red dots, and we just have to do the phase shift. Phase shift is h over b, which equals, in this one, negative 11 pi over 6 divided by 1/3. If I copy dot flop that, I will get negative 33 pi over 6. Divide the top and the bottom by 3. I'll get negative 11 pi over 3. So I'm going to the left. Negative 11 pi over 3. So what is that's about 4 pi, just a little bit less than 4 pi. So every dot is going to move a little bit less than 4 pi to the side, to the left. So 1, 2, 3, a little bit less. This point ended up here. This point, 1, 2, 3, 4, a little bit less. Ends up right about there. And then the period is every 6 pi, so 3 pi later, it's a minimum. 3 pi later, 1, 2, 3, it's back to about there. And we're back to our maximum right about there. So let's keep moving these a little bit less than 4. So 1, 2, 3, 4, so a little bit less. This point, 1, 2, 3, 4, we're off the graph there. So final graph, connect up these orange dots. Best of my ability. Looks a little something like this. Let's take a look at number 26. Yeah, a little bit off right here. I've got it started a little bit lower. But all in all, pretty similar graphs. Close enough. Maybe I'm slightly off with this phase shift or something, but yeah, looks about right. Okay, let's call that good. That was a long one.